All right, and I'm going to do a video now for the last two examples. All right, just some things I want you to be aware of. So simple interest on a short-term loan is sometimes computed in days. For example, the term of a loan may be just 90 days. In this case, we're trying to find out what part of a year that would be. So if we have something in days, then we're going to need to divide by 365 days. And that's going to wind up telling us what part of a year that would be. All right, so some lending institutions might use something called the banker's rule. Now, all that the banker's rule does is it treats every month like it has 30 days, and then it uses 360 days in a year. Now, 360 is a number that a whole lot of things go into, right? That's what makes the computations easier to do. 360 divided by 2, 4 goes into it, 5 goes into it. You know, there's just a bunch of numbers that go into 360 evenly. All right, so let's just check on this. Let's see how that affects the amount of interest. So let's suppose that we're looking for the simple interest on a $5,000 loan, okay? And here are the terms. It's 8% for 90 days. And we're going to use 365 days in a year. So if we're doing that, we just want the interest. We would put in the principal. We'd put in the interest rate written as a decimal. We'd put in the time in years, so 90 days divided by 365. And you can type all that in and calculate it. And when you do, you might have to be careful about that rounding. So let me do it while you're doing it. Okay, and when you type in the 90 over 365, you can really just type in 90 divided by 365. All right, when you do, it turns out that's supposed to be I use like a squiggle when something has been rounded. I wind up getting 98.63, let me leave that dollar sign off for a minute, 0.6301, and there's more. And because it's money, we'd probably round to the hundredth, and that means it's about $98.63, okay? All right, now let's find out how much interest we would owe. So that's interest we would owe for that loan for those 90 days. All right, now let's calculate the interest using the banker's rule. The only difference there is that we're assuming 360 days in a year. So I'm going to take the interest. I'm going to take that $5,000 times the 0.08, but this time I'm going to multiply by 90 over 360. Now here's what's nice about it. 90 divided by 365, that's kind of hard to simplify. So, I mean, they are right in the idea that 90 over 360, 9 goes into 36 4 times, so that's a fourth of a year. Yeah, that's nice. That allows me, when I type this in, I can type in 1/4 right there, okay, instead of typing in 90 over 360. So you can do it with the 1/4, or you can do it with the 90 divided by 360. And what I wind up with is precisely 100, okay? So I would owe $100, okay? So if this were a loan, who's benefiting from them using the banker's rule? Does it benefit me as the consumer, the one who borrowed that money, or is it benefiting the banker who's loaning that money? Aren't you having to pay the banker $100 if they use the banker's rule versus only $98.63? I know it's not much, but it's $1.37 different, okay, for really no reason. The banker benefits. And is that computation really that much easier? Well, It might be if I were doing it by hand because of it simplifying to be 1/4, but is it really that much different if we have access to calculators, which we all do? I mean, typing in 90 divided by 360 versus 90 divided by 365, there's really no difference there. Okay, so the computation is really not any harder. And I'll say nowadays, because we all have access to computers. You know, back if everybody was trying to do all these calculations by hand, then sure, I'd rather be dealing with 1/4 than 90 over 365. So, yeah, no reason to be using the banker's rule anymore. All right, let's look at this situation. This is something that I really hadn't had any experience with. There's a type of loan called a discounted loan. All right, and so let's see what it entails. It's kind of an interesting concept. So what happens with these loans is the interest on the loan is actually paid up front, like right away. And they do that by deducting the amount of interest that would be owed from the amount that you get. So, you know, if you take out a loan, say you take out a loan for, like up here, say if we take out a loan for $5,000, we typically get that $5,000. We make an agreement that we're going to pay it back, you know, after 90 days and all, but we get $5,000 when we walk out the door to go then do what we need to do. It's not how it works with a discounted loan. However much interest you would owe, that has to be deducted. They would deduct that from how much they let you have. All right, so that type of loan is what's called a discounted loan. It's where they take their interest out before the interest you would owe them, before you even get your money. And then the interest that they deduct from the amount they give you, that's what's called the discount. So the discount is really the discount is really just the interest, okay? All right, so let's see how this works. So here's a student that took out a loan for $4,000 for college tuition. It was a 2-year loan, and the rate was 9% simple interest, and the loan was a discounted loan. So first thing we're going to do is calculate then the discount, which is really the interest. So we're just going to use the I equal, for this one, I'll write it over here, the I equal PRT formula. All right, so the interest would equal 4,000 times the rate, 9% is 0.09, times the time. So we'll do that. That turns out to be $720. All right, now here's what's going to happen, is you wouldn't receive $4,000. You wouldn't receive $4,000. What you would receive is 4,000 minus the 720, the interest that you're supposed to pay them. So you would only receive $3,280. You wouldn't walk out the door with 4,000. You'd walk out the door with 3,280. All right, so now we're being asked on this next question to think about this a little bit. So the named interest rate was advertised as 9% simple interest. Okay. But what is the true interest rate on this loan? Let's think about that. So you know how interest is equal to principal times rate times time? Okay. So supposedly I borrowed $4,000, but the reality was I received $3,280. So I'm going to put that in. That was my true principal, the true amount I walked out the door with. The interest I paid was $720. Okay. we're going to look for what the interest rate was, and the time of our loan was 2 years. So I really didn't get to use my $4,000 for those 2 years. Okay, we're going to calculate what our interest rate really turned out to be by solving this. So here's what we're trying to solve. Now we can go ahead and multiply these two together because multiplication is commutative. It doesn't matter what order you do those in. So I could switch around the R and the 2 and go ahead and do 3,280 times 2. And if I did, I'd get 6,560. And that has an R on it, equals 720. Let me go ahead and get my variable on the right like I prefer. And then let me continue that solving process. I'm going to wind up dividing both sides by that 6,560. Okay. If I do that, that should be the decimal form of the interest rate. Okay. And what I wind up with, let me give you the decimal to start with, is 0.109756098. So let me think about that as a percent. So that's going to move over 2 places. So that's going to be 10 point, and gosh, if I do that, let me double check something real quick. I'm just typing it in one more time, making sure I typed in the right thing. 720 divided by 6,560. Yeah, so it's 0.10975 and all. So if I round it even to here, that's going to be 10.98%. So almost an 11% interest rate is really what that loan was. Okay. All right, so it's a little misleading, I feel like. It's deceptive. You know, they advertised as a 9% interest rate, but you're really paying almost 11%. All right, now there's more to interest. There's the idea of compound interest, but I'm going to stop here. That's not going to be included on your test.